Today, we're going to look at how to use matrices and Gaussian solving with row echelon form to figure out how to solve this system of equations where we have three equations in three variables. Okay, so the first thing we're going to do is we're going to put all of the coefficients into a matrix, and then we're going to put all the solutions as well. So that's going to make this what's called an augmented matrix, which just means we're going to augment or add the solutions to our coefficient matrix. So as I write these out, that looks like this. And you'll notice that I put a 0 in wherever I am missing a term. So this equation has no x term. That means its coefficient must have been 0. Same thing, this one has no z, so its coefficient is 0. And otherwise, I'm just pulling the coefficients, right, the numbers that are multiplied to my variable, and writing them and then augmenting with my answers. Okay, so to solve this equation using row echelon form, that means I need to transform this matrix into one that looks like this. All right, the key here is I need this diagonal of ones through my coefficient matrix. And then I need zeros, and nothing but zeros, underneath those ones. Now, these stars here represent that these are going to remain numbers, and they can be whatever they turn out to be. That's going to be my solutions. But the row echelon is this diagonal of ones and zeros beneath it. Now, why is this going to help me? Well, this line right here, right? This one, that's the coefficient of my z, right? These are my x coefficients, my y coefficients, my z coefficients. So essentially, I will, when I finish this, have a statement that says z equals number. And then I'll be able to plug that number into the equation I'll have above, which will say y plus some amount of z equals number. Well, now I know z. So then I solve for y for my final equation, which says x plus some number of y plus some number of z equals number. Well, I plug in my y and my z, and I can find my x. So once I get it in this form, I'm golden. Okay, now, how do I get it in this form? Make the upper left corner entry a 1. Okay, what does that mean? Well, that's this number right here, right? That's the 1 I need to create there. Well, luckily, I've already got one, so I'm cruising. But if I didn't, if there were a 1 in one of these other two left column positions, I could simply take the entire row and switch its position, because it doesn't matter what order I put these in. If it still weren't a 1, then I would use some of my linear combination tricks. And I'm going to show you how to do that in my next steps, which are to create zeros underneath this 1. So my left column is 1, 0, 0. And so that next step is make the rest of the entries in column 1 zeros. Okay, so here I am, and I actually already have one of the zeros, so now I just have to make this a 0. So how do I do that? Well, I'm going to utilize the 1 in this corner. If I multiply this entire row by the opposite of this number, so this is -2, I'm going to multiply by 2. Then when I add, I'll get a 0. So I'm going to give myself instructions. So my new row 3 is going to equal 2 times my row 1 plus my row 3. So I'm going to make a new matrix box, and we're going to execute on that. So there's my row 1 and my row 2 repeated. And now here I'm going to create my new row 3 by following my own instructions. 2 times row 1, that's 2 times 1, plus -2, that gives me that 0 I was looking for. 2 times 1 is 2, plus -3 gives me -1. 2 times 2, that's 2 plus 0 gives me 2. 2 times 4, that's 8, plus -4 gives me 4. And so now I've completed my first 2 steps, a 1 in the left corner and nothing but zeros underneath it. So now I'm ready for step 3, which is to create a 1 in the second row, second column entry. So let's take a look. So that's this guy right here, right? Second row, second column, smack in the middle of my coefficients. And that's creating this one right here. Okay, the easiest way to do that, because we got a 0 here, is just divide this entire row by this number. That'll create a 1. So again, I'm going to leave myself some instructions. So My new row 2 is going to be created by taking my old row 2 and dividing it by -2. And that's going to look like this. Okay, so my row 1 stays the same, my row 3 stays the same, and now I'm going to follow my directions and divide row 2 by -2. 0 divided by -2 is 0. -2 divided by -2 is that 1 I was looking for. 1 divided by -2, that is -1/2. And again, 1 divided by -2, that is -1/2. Okay, we're getting close to the end. Our next step is create a 0 under that 1. And you'll notice I put in parentheses R3, C2, so that's row 3, column 2, just so you can sort of see where we are. Okay, let's make that happen. All right, so row 3, column 2, that's that. Well, I see right here, I've got a 1 right above it. If I add those two together, that'll create a 0. So again, I'm going to leave myself some instructions. So to create my new row 3, I'm going to add row 2 and row 3. And my new matrix, okay, here I go. My new row 3, 0 plus 0 remains 0. 1 plus -1 gets me the 0 I was looking for. -1/2 plus 2 leaves me with 3/2. Plus 4 leaves me with 7/2. Okay, I am almost there. My last step is I need to create a 1 in this last coefficient matrix to create my diagonal. So let's look at that on our list of instructions. Okay, create a 1 in row 3, column 3. Here we go. So how am I going to do that? Well, again, my best way to create a 1 is to divide by what's sitting in there. So let's write our new instructions. So we're going to create our new row 3 by, now I chose to write it as multiplying by the reciprocal. So I'm going to multiply by 2/3. You could divide by 3/2, same thing. So let's create our matrix. Okay, so there's row 1 and row 2, the same as they were. And now let's follow our own directions. 0 times 2/3 is 0. 0 times 2/3 is 0. 3/2 times 2/3 is the 1 we were looking for. And 7/2 times 2/3, those 2's cancel and we're left with 7/3. And if you look, there's the form we were looking for. A 1 with nothing but zeros under it. Any old number, a 1 and nothing but zeros under it. And then any old number, a 1. All right, so we did it. Look at all that work. And now we're ready to solve. So the first thing we've got is this row right here with all the zeros. That essentially tells us that 0x plus 0y plus 1z equals 7/3. We've got our first solution. We're now going to take our second row and write out that equation. So that says that 1y plus -1/2 z equals, that tells us that y plus -1/2 z equals -1/2. Now I have a value for z, so I'm going to plug that in. So now I've got y minus 1/2 times 7/3 equals -1/2. I'm going to go ahead and combine like terms. Now I'm going to add 7/6 to both sides, and I'm left with y equals 4/6 or 2/3. So I have my second solution. And now I'm going to do it again for my top line, where I have that x plus y plus z equals 4, right? 1x plus 1y plus 1z equals 4. I have my y, I have my z, so let's solve. I substitute in my y and my z. I combine like terms. Okay, 9/3 is just 3, which means that x is 1, and I have my third solution. So by taking my system of equations, transforming it into row echelon form and using Gaussian solving, I then create this new matrix, which I can then back solve to get these 3 solutions. All right, keep practicing that. Keep looking for new videos on how to do matrices from me and keep on mathing.